Hello everyone, I'm Aaron Solomon. This video will go over some of the features of the symbol table project. The symbol table project was developed by me as a CS426 senior project in computer science in the years 2014 and 2015 in the Department of Computer Science and Engineering at the University of Nevada, Reno. A symbol table, to start with, is just something that kind of states where things are in a program. Variables, functions, etc. When you're looking at just this thing x, you don't know what it is, you don't know how to use it. And when you're trying to verify that a usage is legal, trying to figure out how to use it or where something is, you need a symbol table to look it up. Most symbol tables will be built for a very specific language. These symbol tables can't be reused. This symbol table is a generic symbol table that can be used for any language. It implements very specific symbol tables using patterns with this general design, and then these patterns can in turn be reused from language to language. And specific patterns can be selected and dropped and so on to support the language features. The symbol table project models a symbol table using a graph, a general graph. The symbols are spread out through this graph and connected to each other using paths. At the center of each path is a gate. When searching for a signature, which identifies a symbol in this graph, that search carries along with it privileges. Gates require privileges in order to get through them. When going through a gate, the gate will first see if it accepts those privileges, and then if it accepts those privileges, it will restrict those privileges to something else. So if you're looking at a variable, you might only have public access to that variable, the members of it. Before moving on, it might be useful to see what kinds of privileges there are in the general symbol table implementation. It includes two defined privileges, a regional privilege and a local privilege. The regional privilege is concerned with interactions between groups. A regional privilege accepts another regional privilege as long as they share some common element. So if two symbols share some common file, they can see each other. A local privilege is a one-on-one interaction. It states that all of its requirements must be met. The provided privilege contains all elements of our local privilege we can go through. The final thing that might be useful to look at is the fuzzy forest fuzzy hasher thing. And this is used by the not anonymous path set, which is searchable. So this will find the closest matching legal signature to a signature we're searching for in a path set. First, it takes the basic properties of a signature, like name, maybe parameter length, maybe component types, and it will create a hash value from these basic properties. And this will in turn point to a very specific fuzzy forest. At this point, it will go over a list of fuzzy trees and it'll look at the roots. When we talk about fuzziness, there's fuzzy equality, and that introduces distance for equality. So how equal are two things? The closer the equality is to 0, the more equal they are. 0 would be an exact match. So if the first tree we find in this forest that has a distance that is not infinity will be a tree that can represent our signature, a tree that will work. There will only ever be one of these trees in the forest. So we find a tree. Now we have this distance from the root. We just calculated it when finding the tree. So with this distance, we go to a very specific ring. So here's ring 1, 2, 3, 4, 5. So if we had a distance of 3, we go to ring 3 over here. And these rings contain signatures on them. So in here, we're just trying to find the first signature that can represent us, the first signature whose distance is not infinity. So we look at this ring, and if we don't find a match, then we go in one ring, and then we go in one ring until we're eventually at the root. The very first match we find will be our closest possible match, will be our best match. So we find a match in here somewhere, and then we're done. We don't have to look at any other tree. We don't have to look at any other forest. That's it. So it's actually a pretty fast, efficient search. The next thing that might be useful to go over is the API for symbol table. Just so up here we have two components that were defined. A component is that corresponds to include features. A component might be things generic. So we have two signatures, and these two signatures are used to create two symbols, signatures that identify them. And then the symbols are compared for equality. Now this will return true because the order of components does not matter, as long as they are the same types of components with the same values. So that will be true. Now here we have three privileges: a local privilege, a regional privilege, and then the union of the two privileges. Privileges can be mixed up of different types. And then privilege except privilege 3 is true because all of privilege's requirements are met by privilege 3, since privilege 3 contains privilege right there. Fine. Next, there's a path to a symbol, and it requires privilege and grants privilege 2. So this must be met by the provided privilege, and this is intersected with the provided privilege to create a new, more strict privilege. Finally, this is the fuzzy tree. Fuzzy trees in symbol table contain paths, and the paths compare with each other using the signatures of the symbols they lead to. When doing a search on a fuzzy tree, it will look for a legal path, so requirements met by the gate.